So we're going to begin in lesson 1.1, and we're going to be exploring functions and function notation. Let's just dive in and look at some of the exercises and the concepts that we'll need to complete those exercises. So right off the bat, you can see I just stole this from our textbook. In the first part of our algebraic exercises, we're simply asked to determine whether a relation represents a function. And so the way we do that is we simply look to make sure that the x-coordinate, that each x-coordinate is not matched with more than one y value. So right away in number 6, I noticed that A is matched with B, but A is also matched with C. So this is not a function. In number 7, A is matched with B, B is matched with C, and C is matched with C. The x-coordinates are only matched with one y value. It is okay that this y value C is used twice. We just can't have the x values be matched with two different y values. So this is a yes. This one is a function. And as we move into the next section, instead of giving us sets of ordered pairs, what we're going to do is look at expressions. So in general, you want to make sure that your y value, the y variable, does not have an exponent on it. That's, in a nutshell, that's what we're talking about. There's a couple other places that we have to be careful of too. But for example, number 8, this is a linear function. We know those are functions. It's right in the name, right? This is a standard form for the equation of a line. So it is a function. This is a yes. If you take a look at number 12, 2x plus y squared equals 6. This is not going to be a function. And one of the reasons it's not a function is if you try to solve for y, you actually get two pieces. You get y equals the positive square root of 6 minus 2x and the negative square root of 6 minus 2x. And when you graph each of those pieces, you'll find out that you won't pass the vertical line test. So one of the tests for these expressions is if you can solve for y and just have one equation, you might be in good shape. For example, not here, down here in number 20, the original problem is not written with y as a function of x. However, I can solve for y by just taking the cube root, and we don't have to worry about positive and negative cube roots. There's only one cube root. So we can change this into y equals the cube root of x. And this is a function. So you're going to use those properties that we know about functions, specifically that vertical line test where the x value can't have two associated y values. And the things that you know about expressions for functions to decide if these are functions or not. Give it a go, and then we will go over these after you've tried your exercises and follow up to make sure you're doing them right. In the next set of exercises, you're asked to evaluate function f for some specific x values. F of negative 3, f of negative 2, f of negative a, negative f of a, and f of a plus h. I'm just going to run through this process with you with number 27 just to make sure you remember how to plug these values in. So our function is f of x, and I'm going to write the x in red here just to drive home the point that we are replacing x with whatever is in the parentheses of the function notation. Our f of x equals 2x minus 5. So whatever I put in the parentheses here, I'm going to insert in place of x there. And I want to multiply it by 2, so I'm going to use parentheses to insert whatever I need to in there. For example, if we're doing f of negative 3, then I am going to do 2 times negative 3. Oops, this is an equal sign. minus 5. 2 times negative 3 is negative 6. Minus 5 is negative 11. So f of negative 3 is negative 11. Believe it or not, that says negative 11, even though it doesn't look like it. Oops, wrong color. Okay, that looks more like 11, hopefully. Let's do f of 2. That would be 2 times 2 minus 5. 4 minus 5 is negative 1. F of negative a, and they literally want us to use the letter a there. All right, so we're going to put in where x is the opposite of a and then multiply this out. That'd be 2 times the opposite of a, which is negative 2a, and then minus 5. We can't simplify that thing any further. Right? These are not like terms, so we just stop. I forgot to highlight my negative 1. Next, we're doing negative f of a. So there's a couple things going on here. This negative sign on the outside, I'm looking for an eraser here. This negative sign on the outside acts like a multiplication by negative 1. So when you see something like this, you should be thinking that this is negative 1 times whatever f of a is. And so when we write this out, I'm going to write negative 1 times the quantity 2 times a minus 5. And so I'm going to have negative 2a plus 5 for this one. Notice the result ends up a little bit different than the last one, and that's okay. We figure out what f of a is and then multiply by negative 1. We distribute it through. Okay. And then finally, f of a plus h. A plus h is a binomial. And so when we plug it into the function, we just need to make sure again that we use those parentheses. Squishing it together here a little bit. So we distribute the 2 and we get 2a plus 2h minus 5. And that's the result for that one. So for the problems in this section, you have to do 1, 2, 3, 4, 5 different answers. You'll evaluate the function 5 times. Be careful with the negative a, the negative f of a, and the a plus h, because there's extra math that you need to be aware of there. Moving on. In this set of exercises, we are simply using the vertical line test to determine whether these relations are functions. So basically the vertical lines test says if you drew a bunch of vertical lines intersecting this function, as long as you only intersect the function in one place, you're good to go. So I'll just do 40 and 41 here. On number 40, no matter where we draw a vertical line, we only intersect our curve in one dot, right? You don't have to draw a bunch of vertical lines. You can see that we're always only going to hit the blue with one dot. On number 41, though, when I draw a vertical line, and almost every vertical line that I draw, this happens, I hit the curve in 2 spots. So what that means is the x values are associated with 2 y values. That is not a function. That's just a relation. So keeping that in mind, I'll have you work on some of these graphs using the vertical line test. In the next set of exercises, we are going to use a particular graph of a function to evaluate a function and to solve. So let's start with trying to evaluate f of negative 1. And again, we're using this graph. So what you do for these problems, like letter A, when you're evaluating, you go to negative 1 on the x-axis, and then you find the y value. So in this case, you'll see that at x equals negative 1, the y value is 1. So when I evaluate f of negative 1, I get 1. For solving f of x equals 3, instead of going to the x-axis, we go to the y-axis. So what I want to do is I want to go to y equals 3 and move out until I hit the curve. And it looks like it's going to actually be at 6, which isn't easy to see there. So for evaluating, you start on the x-axis and you move up to the curve. For solving, you start at the y-axis and move out to the curve, left or right. And that's how you get those values. There may be more than one answer for some of these problems. For example, in number 53, there should only be one answer for f of 0 because this is a function. And that is true. If I go to 0 on the x-axis, the only y value that I have associated with 0 is 1. However, if I go to negative 3 on the y, there are 2 places where that y value is used. And remember, that's okay. So the answers for this one are x equals 2 and x equals negative 2. It's okay if y values get used more than once. It's not okay for a function if the x values get used more than once. So now what I'm going to do is I'm going to move, oops, just made a mess there. So I'm going to move to a different part of this picture here and talk about one-to-one functions. So if you did the reading, you'll remember that for one-to-one functions, there's 2 things we're looking for. First of all, is it a function? And secondly, is it one-to-one? For something to be a function, it has to pass the vertical line test. For something to be one-to-one, it has to pass a horizontal line test. So I'm just going to take a look at number 56 here. If I draw vertical lines, I'm okay. This is a function, right? I only intersect my blue line in one spot. But if I start drawing horizontal lines, I fail that test because I hit the blue function in 2 places. So number 56 is not one-to-one. It's a function, but it's not one-to-one. Because although it passes a vertical line test, which means it is a function, it fails the horizontal line test, so it's not one-to-one. And the reason that we're curious about one-to-one functions is those are the functions whose inverse is also a function. And when we work with inverse functions, it's going to be important that we make sure we're dealing with a one-to-one situation. As we move on through the exercises, we get to the numeric section, and we're going to be practicing some of the same concepts that we did earlier. For example, we're just trying to decide if these relations represent a function. So in number 60, we look at the x-coordinates and we make sure that they're not associated with 2 different y values. In the case of number 60, negative 1, negative 2, and negative 3 are all only associated with one y value, so this is a yes for functions. This is a function. Down here for number 63, we're trying to find out if this is a function. We want to know if y is a function of x, right? So again, we look at the x values and we just make sure they're not associated with 2 y values. Remember, y can repeat, but we can't have x being matched up with 2. So essentially, x can't repeat. So this one's a function. This is okay. And then finally down here toward the end, we're just going to evaluate and solve. So remember, evaluate means find the y value associated with that x. And solve means find the x associated with that y value. So you'll use this table to answer those 2 questions. Toward the end of our assignment, we're working with some technology problems. And that's a fancy way of saying we're either going to need to use some sort of software or some sort of calculator. I'm going to recommend that for these problems you use Desmos, either on a website on your computer or use the app on your device. In this case, we are supposed to graph y equals x squared on the given viewing window. So when they give you this viewing window, They're giving you the x values, the values that they want to display on the x-axis. You're still going to have to search to find the y values. And then what we're going to do is, after we determine the corresponding range, we will have our graph fitting in that window. So let me show you what I mean. So for starters, we go ahead and fire up Desmos. You'll notice that I typed in y equals x squared, and my function appeared over here in blue, right? This is y equals x squared, that parabola that we're used to. Ooh, I almost drew it right on top of there. That was pretty good. And notice right now my viewing window goes from -10 to 10 on the x-axis and from -10 to 10 on the y-axis. That's typically your home screen, your home viewing window. When you're not in the home position, there will be a little home button that pops up right here. The home button's not viewing now because we're already in the home position. Okay, so the first thing that they give us in the problem is a new viewing window. They say we want to view this from, instead of -10 to 10, we want to go from -0.1, which is in here somewhere, to 0.1. And what we want to end up doing is we want to end up making it so that we zoom just in on that piece of the graph. So it's almost like we're stretching this picture out and we're zooming in until just this little piece that's in the red shows up. And I'll show you how to do that on the next screen. We're going to basically change the range on the x-axis and the range on the y-axis. The way you adjust the axes is you access your wrench tool, which is this guy right here. When you do that, this box pops up. And what I've done is I've typed in exactly what the problem told me to type in. I put a -0.1 for the lower bound for x and a +0.1 for the upper bound on x. And you'll notice in the picture that my curve essentially almost disappears, right? It almost looks like the x-axis now. There is barely a blue curve there. But because we changed the zoom on the x-axis to go from -0.1 to 0.1, we really distorted this graph. We no longer want to be going from -10 to 10. -10 got covered up by my keyboard, but it's down here. We don't want that to be our range on our y-axis. So what we're going to need to do is we're going to need to change these numbers as well. And you could do this by trial and error if you wanted to use your fingers until you got it right in the right position. But what I decided to do was use a little bit about what I know about these parabolas to help me. So this is just y equals x squared. I know the lowest value on the y-axis is 0. So I'm just going to change this number here to a 0. And then the highest y value is just going to be whatever the outermost number squared is, and 0.1 squared is 0.01. So when I go ahead and adjust this, I'm going to put a 0.01 in here, and I'll show you what that looks like on the next screen. Once I've made that adjustment on the y-axis, you can see now I have this parabola back in a good viewing window. And notice I'm from -1. Oops, I didn't really want to use a highlighter there. Let me just undo that. Let me get a red pen. It won't undo. Maybe it'll erase. Yes, it'll erase. Okay, so now let me get my red pen. Sorry. Notice I've got the window they asked for. I'm going from -0.1 to 0.1 on the x-axis, so that's good. And then I've completely filled in the range by changing the numbers on the y-axis. So the lowest I'm at is 0 here, and the highest I get to is at both of these outer points, I get to 0.1. And now that parabola has filled the viewing window. Ultimately, this is what it's supposed to look like when we're all done. So I just tapped the wrench to make it go away right here. And now I can see my curve in the viewing window that they requested. This takes a little getting used to, and you could always use your fingers to zoom in and zoom out until it looked the way you wanted it if you're using your phone. If you're using the website, it's a little easier just to go ahead and do it with the wrench tool. And I can help you if you get stuck choosing especially the Y values. The X values are easy because they give them to you. So you just type those in the wrench tool. But the Y values, it takes a little experience to decide what the appropriate range is for Y. I think that's enough for now. I did a lot of talking. This is probably more than one day's worth of work, but you've got the reference here in the video if you need it. Anytime you have questions on this stuff, please feel free to ask. You know how to get a hold of me. I'm happy to help. Good luck, and we'll see you soon.